My name is Henning. As mentioned, I'm a consultant at Webstep, and today I get to talk about Mechanical Turk. So I'm going to talk a little bit about what Mechanical Turk is, how you might use it, how to get started. We're going to run through a small example. We're going to talk a little bit about the cost of Mechanical Turk. It's not free. And then I'm going to talk a little bit about what alternatives to Mechanical Turk there might be. Um, so Mechanical Turk has come a long way in some respects. It was actually founded in 2005 as a separate company. It was later bought by Amazon. And as you can see, they kind of market themselves as an on-demand workforce for micro tasks. That's a pretty abstract word, but Mechanical Turk really started becoming popular when machine learning got popular, because it lets you, these micro tasks can be stuff like this, like categorizing text, or categorizing images for your computer vision machine learning, or it can be used to pretend like you have a really cool machine learning model while all you do is just push the work over to Mechanical Turk. And just to kind of highlight the versatility of Mechanical Turk, it's worth mentioning that Mechanical Turk is also mentioned in academia a lot. People have even conducted entire game theory experiments on Mechanical Turk. So there's really a lot you can do here with a relatively simple framework, really. But for our purposes, mechanical machine learning is probably what most people are interested in doing, and so we're going to go through a little bit about Mechanical Turk in the context of machine learning and in the context of current AWS users. So Mechanical Turk lives in kind of a weird place in the AWS landscape. You won't find Mechanical Turk on the console in AWS. Interestingly, you will find Mechanical Turk on the SDK. But if you're really interested in starting like proper Mechanical Turk, there's a website, mturk.com, where you can get started. But as mentioned, this has gotten really popular, and there is an integration with AWS beside the SDK, which is named SageMaker Labeling Jobs. And this is what we're going to dive a little bit more into today. This is really just a thin veneer over Mechanical Turk. The basic simplicity of this is bewildering, and like many AWS services, this is just several other AWS or Amazon services duct taped together. So it's basically S3 labeled on duct taped onto each side of Mechanical Turk. So you have your input in an S3 bucket. It gets piped to Mechanical Turk, and your output gets put in an S3 bucket. That's the basic premise of the SageMaker labeling jobs. We'll see an example of that. But just remember, this is fundamentally a very simple process. So hopefully this is simple enough that I'll actually be able to show it. I have the SageMaker labeling site here. Hopefully you can see that. And we're going to create a labeling job. let's see, we can name this anything we want. Good morning with Webstep is a fitting name. As mentioned, we need an input bucket. And because I like to keep things tidy, I want the output to be somewhere other than the input. We're going for the so-called automated data setup here, and this is kind of a weird, finicky thing. The labeling jobs require a so-called manifest, which is basically a file that displays all the input objects to the labeling job. So it's basically like a manifest. And this manifest has to have a certain structure. And if you're just getting started with this, that can be a little bit finicky to create. After you've done it a couple of times, you might prefer to do this yourself. But the input here is an S3 bucket. I have a bunch of images here, and this is what we're going to create the manifest for. Just to give a little bit of context, the images are plots like these. And what I want to ask is, which plot looks more random? This might seem like a really, really contrived example, but if you remember the iPod shuffle debacle many years ago, humans don't really deal well with random. And so you might even get a paper out of creating some generative neural net that creates more random looking distributions to the human eye. So it's not quite as contrived as it seems. But okay, we are basically where we need to go. AWS has the information it needs to create this manifest. So if we run the data setup, you're not going to see a lot of changes, but you will see if we refresh our bucket here, there's going to be actually two manifest files. These manifests, as mentioned, they're kind of finicky. I've already downloaded a similar one, and they basically look like this. This is almost JSON. They're so-called JSON-L files, or new line delimited JSON files. The big advantage of using new line delimited JSON is that you don't need to parse the entire file to get one item for labeling. Whenever a worker gets hits the labeling interface, AWS only needs to read one line of the file, not the entire file. So this might be a very new format to some. If you like JSON, then this is going to seem really strange. But it is a nice format for this task. We're going to label the full data set, and you have to choose the task type, which is basically what's going to dictate the interface the worker sees. You have a lot of options here. Some of these are going to look very familiar. Some of these might look a little bit less familiar. They have some really strange ones here relating to self-driving cars. You also have, we're not going to do this, but I want to show this because this is what really ties, where you really can see the tie between Mechanical Turk and the labeling jobs. You have a custom template, which actually uses templates that lets you, these are the same templates that Mechanical Turk uses, and you can really customize your input like this. You see there are HTML elements, and you can input your own CSS here. But they're a little bit more finicky than the most simple task. It also requires a pre-labeling and post-labeling function, a Lambda function. The pre-labeling function basically just takes one item from your input bucket and outputs, well, some JSON that goes into this. It's really it really has strong opinions about what keys should be in that JSON file. So debugging this and getting started is, yeah, can be really annoying. Same thing with the post-labeling task. It takes as input the output from the labeling task, and the output, the function should return is whatever gets stored into S3 as the output. Luckily for our purposes, we don't need any of that right now. We can go for the image classification task. That's precisely what we need. Now, here we go to the options. I think a lot of people don't know this, is that you can have private labeling tasks. That's something particular to the SageMaker labeling jobs. So you can have your own team. This is going to be your, this is basically just going to be a Cognito user group. So they're not too hard to set up. You can invite colleagues, and you can have an entire private labeling jobs with help from your entire team. We're going to do this with Mechanical Turk, which means we also have to set a price point. I'm guessing just going with the random or not random task is going to be pretty short task, so 5 seconds might be all we need. There's one thing here that is really important to know, especially if you're worried about costs. Because these are kind of random workers, a random worker pool that we don't have a lot of control of, you might not want to trust any single annotator's response. So you might want more than one people to annotate this. And that's usually a good option. So we need to fill in a little bit here because we want the worker to have some description of the task. And I just want to highlight that this is a personal perception issue. We want two alternatives, left and right. Those will be the two labels we have. And you can preview what this is going to look like. This is a really nice feature. You're probably going to be spending a lot of time here, or you should be spending a lot of time here, because this is the user interface. This is what the worker is going to see, and this is going to be central to the quality of the data you get back. So we're just about ready to start. Hopefully this will work. We are not getting any error messages here. You can still get an error message after creating the job, because there are, if you have any gunk in your input data, basically, then you might get some error messages after you start the job. Yes, I need to check that this is not adult content and that I understand that my randomly generated plots will be public. So okay, so far so good, and we're not gonna wait for this. We're gonna switch back. So okay, no error messages, which means I can skip some of these. If you're working with text, the process is just slightly different. Your input can be just one large text file with one item per line, and you can generate the manifest automatically. Or you might want to generate the manifest yourself. Instead of a source ref key, you have a source key. When you're not actually linking to the image, when you just have the text in the manifest itself. The nice thing here is that you can add metadata. You can add more keys. SageMaker is really particular. It wants a source field or a source ref field. It will give you an error if there's not one of those present. This metadata is going to just get passed through the entire job. So you'll find this in the output again. Let's see, we've already seen this and we've seen this. Excellent. So the output, this is something we haven't seen. What gets stored in S3 is basically something like this. We have the objects itself, and you have the annotations as an array. And so you have a really, well, you need to parse some stuff. And if you have several annotations per object, you need to kind of make sure that you end up with perhaps one label per unique object. Amazon can do some of that for you, but I'm guessing you want to dive into the actual JSON output. This example is going to cost me a few dollars. We've already seen the price we pay the workers, but in addition to that, AWS takes 8 cents per item labeled. So this has nothing to do with how many annotators we have. This is just a fixed cost per, in my case, per plot. So 8 cents times 100, I'm going to be paying Amazon $8. I'll be paying the workers $3.60. Usually, you have more annotators. You pay them a little bit more than just 1.2 cents. The worker cost is going to be more than the AWS cost, but still, it's this is the basic pricing structure here. And in order to keep this cost down, there are a couple of things you can do. Don't label the same thing twice. This has really got to do with your input data. It might or might not contain duplicates. And don't label garbage. This is kind of difficult to check for programmatically with images, but if you have some security camera or something, you might have images that are practically just black. You don't need to waste workers' time trying to categorize if a completely black image is a dog or a cat. The most important thing, though, is only label what the machine can't. This is a pretty new technique, but it's basically the premise: don't start off labeling your entire data set. Label a portion of it and train a small model and see how it does. For categorical inputs, for categorical tasks, the model can easily output a confidence score. So if the model is 99% sure this is a cat, don't waste time having humans annotating it. If the model is really unsure if this is a cat or a dog, those are the items you want to have manually annotated. And this really can save you a lot of time. AWS even has just a checkbox option that lets you train that actually lets you train a model alongside this, and that model is used as the decider as to which of your labeling data is going to get labeled. The interesting output of that is not the model, it's the the money you'll save by not labeling a lot of obvious cases. there are some options here. The labeling business is a big business. There are entire companies who has a lot of their business simply providing the platform, and not to mention a more a more technical, experienced, more vetted crowd for doing the labeling tasks. Another option is Google Cloud. Of course, being Google Cloud, their product is both in beta and abandoned. So, and they didn't bother to tell me any of that until I'd actually uploaded a data set to label. So no surprises there. And you have a product called Prodigy. This is really one of my favorites. If you're a single data scientist who has to do the labeling work yourself, and if you like Python, this is really something to look into. It's created specifically for these kind of Lone Ranger data scientists who have to do the labeling themselves. And it really optimizes the efficiency with which you can do this. It has the active learning component built in, so there's a model in the loop that kind of chooses which items you should label. And I've used this quite a bit myself, actually. And as long as, you know, this is just basically a Python package. You can keep this in-house. And the only thing to mention here is that this is not crowdsourcing. This is not made for a team of people to do the labeling task together. This is created specifically for data scientists, single data scientists, to do the labeling. It comes from the people who made Spacey. It's a perpetual license, so you pay once, you keep it forever. I think if you're considering AWS and for some reason you might not like the pricing structure, or you can't have your data in a public cloud, this is perhaps the most viable options for you.